Good morning to all. Today's topic is switchgear. It's part 2. In part 1, we have discussed what is switchgear, what is its purpose, and what is isolator, switch, and circuit breaker, and differentiation between these three and their functioning. So in part 2, we will learn about miniature circuit breaker. So let us start. So what is an MCB? It is miniature circuit breaker. It is an electromechanical device which protects the circuit from overload as well as short circuit conditions. It can be operated manually as a switch, and automatically it will work when short circuit or overloading conditions occurs in the circuit. Its rating is in amperes. So standard rating is 6 amperes for lightning circuits, like 10 ampere for large lightning circuits and 32 ampere for power circuits, and so on. It goes up to 100 amperes. Its short circuit rating is in kiloamperes. Short circuit rating means short circuit current up to which MCB provides the protection without damaging itself. So it could be up to 6 kiloamperes. So this is an MCB we are using in domestic purposes. So here you can see its diagram. So it's the cable terminal input at the top, you can see it's the cable terminal, and then the contacts. So it will make or break accordingly, and then is the operating handle. You can operate it manually and use it as a switch, and automatically it will operate when there are short circuit or overloading in the circuit. So then is the coil assembly, that is electromagnetic relay. This coil assembly or electromagnetic relay works when short circuit occurs. Bimetallic strip, it functions when there is overloading of the circuit. So you can see there are two basic elements. One is the coil assembly and other is the bimetallic strip. Coil assembly is for short circuit and bimetallic strip is for overloading conditions. Because in case of overloading conditions, the current which flows through the circuit is nearly double the times or more than this, but not so higher as in the case with short circuit conditions. In short circuit conditions, current is very high. It may be 6 to 7 times of the normal rating. So there are these two different protections are provided by two different elements. The bimetallic strip is for overloading conditions, and short circuit for short circuit conditions, for short circuit protection, there is coil assembly, that is electromagnetic relay, because its operation is very instant. It operates very fast as compared to bimetallic strip. Then is the cable terminal. This is output. So from cable terminal 1, input is given to the MCB, and from cable terminal 2, the output is taken from the MCB. Then is the DIN rail mounting. So these MCBs are mounted on the DIN rail. So this is the groove you can see here for DIN rail mounting. Then is the arc chamber. Arc chamber, it basically provides the arc extinction. So when the contacts get opened, there is the arc between those contacts. So by this arc chambers, the lengthening of arc occurs due to the lengthening of the arc. As R is directly proportional to L, when the lengthening of the arc occurs, the resistance increases and the voltage drop also increases, and the system voltage does not maintain, can't maintain this voltage drop. So finally the arc will get extinguished. So this is the diagram for an MCB. These are some basic parts. So there are two types of operations. One is thermal operation and second one is magnetic operation. Thermal operation is provided by bimetallic strip, as we have seen in the diagram. In bimetallic strip, it is a combination of two metals having different temperature coefficient. Means there are two metals which are combined together, so they have different temperature coefficient. One metal in simple language, you can say one metal bends earlier as compared to the other one. Due to this, when the overloading occurs on the system, the one metal bends and it will open its contacts. So this is due to the thermal effect of the current. There is a thermal effect in the current, that is when it flows through the wire or through any conductor, it heats up. It heats up that material. So this effect of the current is used for providing overloading protection in MCB through bimetallic strip. Then is the magnetic operation. As we know, current is having magnetic effect. When current flows through the coil, it will make that coil a magnet. So the poles develop at the ends of that coil. So this effect of the current is used to provide short circuit protection in an MCB. So it is provided via electromagnetic relay, as we have seen in the diagram. So the two operations are thermal and magnetic. Thermal is for overloading protection and magnetic is for short circuit protection. Thermal effect of the current is used in bimetallic strip and magnetic effect of the current is used in electromagnetic relay.